Welcome to Embedded Edge, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on embedded systems technologies and products featured on embedded.com and through other AspenCore media publications. In this show, you'll hear both engineers and executives discuss news, challenges and opportunities for embedded systems design in markets such as automotive, industrial, aerospace and consumer. Here is your host, Editor-in-Chief of Power Electronics News and Embedded.com, Maurizio Di Paolo Emilio.
Hello everyone and welcome to another episode of Embedded Edge, where we explore the technologies shaping the future of embedded systems. Today's episode is brought to you by our sponsor Infineon. In today's hyper-connected world, embedded and IoT devices are everywhere, from our homes to critical industrial systems. But with this connectivity comes vulnerability. Cybersecurity is no longer just a software issue. It's a holistic challenge shaped by hardware regulations, cryptography, and the evolving threat landscape. In this episode, our guest is Clark Jarvis, software and tools technical marketer at Infineon. The title of this episode is Securing the Edge, Infineon on the Future of IoT Security. Building on over 2 decades of product experience for embedded software and development tools, Clark focuses on creating efficient and intuitive design experiences to help embedded engineers with the development of IoT industrial applications. In this episode, we dive deep into security topic and how Infineon is addressing different challenges, helping developers secure devices throughout their life cycle, from prototype to production, while ensuring compliance with global standards. We will explore the concepts of root of trust, chain of authentication, consumer versus industrial risks, and even look ahead to post-quantum security. Let's talk with Clark. Hi Clark, thanks a lot for being here at the new episode of Embedded Edge. How are you? How's it going?
Yeah, good, Maurizio. Thank you. I'm doing good.
Thanks a lot for being here. So where are you located, Clark?
I'm located in Austin, Texas.
Good. So today, Clark, we will talk about security, IoT security, securing the edge, as I mentioned at the beginning in terms of title. But before going forward, before diving into the technical topics, so we would like to know more about you. So please introduce yourself. Tell us a bit about your background and share how you became involved in IoT security.
Yeah, absolutely. So I've been in this industry, I guess now going on a little over 20 years, working at a variety of different silicon manufacturers. And personally, I've always loved making things, and that's worked its way into many of my hobbies, including things like electronics. And so I've always enjoyed kind of the various maker environments and the ecosystems that cater to makers and hobbyists, and the ease of use aspects that they bring. Now, career-wise, I've kind of taken that. I've focused on improving the efficiencies of developers through tools and software and ecosystems, really trying to leverage a lot of those ease of use aspects that you see in the hobbyist and maker communities and striving to apply them to kind of real world product development. Now, as far as security goes, I recall one time having a discussion, this was, a decade or more ago, having a discussion with a developer, and I had the opportunity to work with them kind of off and on throughout the development phase of the product. And in the early phases of their product, there was this mantra of like, oh, security is super important for this product, right? They were like, security, right? That was a big part of the product. And then it turned out at the end of this product, kind of asking them like, well, what did you do from a security perspective, right? What kind of features did they implement? And what did how it went? And the response was, well, it actually ended up being too hard and they skipped it. So it went from like, yeah, security is important to we just kind of gave up on it. And that was a bit eye-opening for me at the time, because I'd been focused on so many other aspects of the development process. And, security for me, even at that time, was just kind of an afterthought. And I realized, right, in order for security to be achievable, it has to also be easy to implement. So that's really shifted my focus, right, to saying, we have to make security as easy to use as we do kind of the rest of the stuff, particularly in products we have today. A decade ago, that probably was fine, right? I could have gotten by with just some basic security capabilities, but that doesn't work that way in today's IoT.
Good. Thank you. So, and during the course of this podcast, we will try to know more about security. So I have a couple of questions to share with you. So let's start with my first topic. So let's start talking about connected devices. So, with more connected devices, the attack surface expands dramatically. So not only in terms of industrial systems, but also from consumer for consumer devices. So what are today's main vulnerabilities for IoT and embedded devices, and why is security now a must-have rather than a feature?
Yeah. Kind of as I mentioned, right? Like early on in my career, right, it was not common for every device to be as connected as they are today, and security was important, a decade or so ago, but it was kind of relegated to infrastructure products or back-end systems, and a lot of effort would go into the security of these products. But nobody was really worried about, can your coffee maker be hacked? Worst case, right, where your coffee comes out tasting bad or something like that. But now I've got a coffee maker that's connected to my home network. It may even be connected to some type of e-commerce system, so it can order repods, it can reorder pods or something like that. It may have your banking details. So suddenly, these kind of everyday devices are connected, and that connection brings several new attack surfaces, right? It brings entry points for malicious behavior, malicious software. We've got information on these devices, right? So I have to worry about the sensitivity of personal information that could be leaked. So there's a lot going on when we look at a modern product and how it's connected and how it's used inside of our customers' environments. Now, from a product developer perspective, I also want to protect the integrity of my company name. I don't want someone to be able to run code on the device that's not certified by me, that can do things that I don't intend it to be done. And even down to the manufacturing of the device. I want to make sure that the manufacturing is genuine, that's using genuine parts. So these are all various aspects that I've got to pay attention to when I'm creating a product today, and with challenges that didn't exist in the past, right? With their real world impacts that can have damaging effects if not done properly.
So let's talk about regulations. So global security regulations are becoming are becoming stricter. So impacting the entire life cycle in terms of product, in terms of system. I mean, from prototyping to also large-scale deployment. So just to adopt in terms of adoption for the market. So how evolving regulations would affect IoT product development, and so what about Infineon? How you are helping customers to manage device security correctly across lifecycle states?
Yeah. Certainly, global security regulations are becoming very critical. It's part of the global supply chain. It affects product development. We've got regulations that are coming into effect in the near future. Things like the EU's Cyber Resilient Act, the CRA. We've got regulatory guidance coming from global DCA. We've got compliance standards that are part of the Radio Equipment Directive, the RED articles. So there are a lot of regulations, legislations that are coming that are going to have a direct impact and requirements to say products need to align to these standards. And additionally, beyond that, then you have standards and certifications. You have things like CSIP, PSA, and they each have their own varying level of security implementations or levels. And with these new regulations being adopted and enforced, right, it can feel daunting, right? It can feel kind of overwhelming to ensure, okay, I'm working on a product. I have to not only meet these regulatory requirements, but I need to get different certifications. And a lot of investment goes into the development of a product. And if suddenly I have to go back and re-architect some portion because there's some new legislation or new regulations that come out, or even worse, let's say there's actual public security issue, right? That can be very detrimental and things we have to pay attention to. And so, I mean, we fully acknowledge, right, that this is a challenging path. So Infineon has defined, we refer to them as the Edge Protect categories. You'll see them kind of referred to sometimes as EPC, but they're Edge Protect categories. We have it ranging from a level 1 to a level 4. And the purpose of these categories is really to help a developer just more easily grasp and understand what the various certification levels are, which ones are achievable, what hardware and software elements are actually going to be used to implement these different security features, and what security features are leveraged in the product. So we start with like a Edge Protect category level 1, right? The lowest level. And you're going to get basic security concepts, things like the ability to do a secure boot or to do a firmware update in the field. And with these features, you're able to achieve like a CSIP level 1, a PSA level 1 or 2, as well as class 1 within the Cyber Resilience Act. So it's nice and kind of laid out, and I know exactly what I'm able to achieve. And then we can go all the way to the top end to look at this level 4 category, which is going to leverage things like advanced hardware accelerated cryptography. I've got isolated secure enclaves, right? Getting into some very rich features on the security side to achieve some of the highest levels of security certification and classification. And then in addition to that, there's a variety of policy tools and provisioning workflows, right? Actual tools that I use that are going to help support exactly how these features are leveraged and enforced during the development phase of a product, as well as how additional features are enforced as the device is provisioned into a production lifecycle, right? So I go from development to production, and I'm ensuring that everything is done in a very secured flow way. I'm establishing and maintaining a root of trust all the way through that's architected into the device itself.
So we mentioned in terms of markets, consumer, industrial, and it would be nice maybe to highlight which are the differences from security point of view. But before that, let me share the topic about root of trust. So at the core of secure devices lies the root of trust, ensuring a reliable authentication chain. So tell us more about how this works. So what mechanism ensure that authentication and signed certificates remain secure in terms of lifecycle solutions?
Yeah, so certainly root trust is central to probably the majority of the security features that we've talked about and we're going to talk about. And the root of trust really enables the device to first be authenticated, right? First, I'm assuring that this is a genuine device. I know this device came from Infineon. I can trust that its origins, where it was manufactured. And then it allows for developers to create specific keys, where these are encryption keys. They're creating certificates that, when programmed into the device, will not only allow the authenticated firmware to boot, but it then allows also me to leverage the security aspects, right? The various keys that I generated, so I can establish secure communication channels, and to be able to just know that the device is operating in an authenticated way. Infineon also leverages, we have a signing service. And this is actually what allows the developer to generate certificates that are signed by Infineon that create effectively a secure ownership transfer. So the device comes from the factory. We'd say the owner is Infineon. It's certified to only work with Infineon-related content. But then the developer is able to transfer this ownership, right? This is ensuring that chain of trust or root of trust is founded upon and extended then to the developer, so that they can then are the authorized owners and the ones that can execute their code on. And it's really the heart of establishing that and maintaining that root of trust.
So security needs different things in terms of consumer IoT devices at home and industrial equipment, as I mentioned just before the previous questions. So what are the key differences between consumer IoT, industrial IoT security? So how should engineers prioritize risks in each domain?
Yeah, many of the security concepts that we're talking about, they're completely applicable to both consumer IoT devices as well as devices that are being deployed into kind of industrial settings. But in both cases, what's interesting is we see both consumer devices and industrial devices becoming increasingly connected, right? There are benefits to both the consumer as well as the industry where these devices are being deployed to have them connected, to have them accessible. Two of the biggest differences that I think I've seen that might impact how a developer would approach security would probably be the type of users that are using these devices, and then the length of time that a product is in service. For a consumer IoT product, you have a wide range of users, and they're placed into a very wide range of settings. So you have to be a lot more flexible and kind of like, how is somebody going to use this device? And so it requires a little bit of an extra vigilance from a security perspective, because you're going to have lots of users, and these users are not necessarily going to be security minded, right? When they're using the devices, they just expect the device to work, and to work everywhere and anywhere. But they're also, they can potentially place the devices in situations where they need to be a little bit more protected, right? There's increased security vulnerabilities. And then there's also increased security vulnerabilities because a user's placing personal information on these devices, and that has to be handled correctly. So it's really kind of that user base and how the user is working with these consumer devices that a developer needs to pay attention to. Now, on the industrial side, they also are becoming more and more connected, but they're also a little bit more controlled. They're typically placed in an environment that's a little bit more known. The users are a little bit more known. But while a typical consumer IoT device might be in use for, maybe 6 to 8 years, it's not uncommon for industrial equipment to be deployed for 10 to 15 years, right? Twice that long. And so it makes it really critical for a device to be able to be security updated, because we don't know what type of security vulnerabilities we're going to see, 10 years from now. But there'll be devices that are deployed now. They're going to have to address those security vulnerabilities, and these vulnerabilities evolve over time.
So talking about security, so I would like to share another topic in terms of hardware and software. So true device protection requires, in terms of hardware-based features, but also a strong software, robust software frameworks. So is there a balance when designers are engineers designing security in terms of hardware and software? So when one layer will be more critical than the other one?
Sure. Yeah. I think that maybe the biggest realization that, neither hardware alone or software alone can really fully implement security. And I mean, even looking at it another way, you could have the most advanced, hardened hardware from a security perspective, but if you put poorly implemented software on that device, you can completely compromise that hardware. There's no doubt about that. Okay. And I think vice versa as well. Like, even if you had the best software, right, the most hardware or security focused software, it's not going to be effective or efficient if it's not able to leverage some of the hardware security capabilities. So they really are intended to be used together. Now, I think it's critical to think of security within hardware and software is really kind of working in concert together. Security features and hardware are probably going to be one of the primary drivers in the level of security that can be achieved, right? So when we talked earlier about some of the global regulations and certifications that are possible, hardware is oftentimes going to be a key factor there. Like, I need to achieve this level of security, so I need to select the hardware that's going to be able to allow me to achieve that. Now, software, when I get to the software security implementation, that can typically be used across a wide range of the various security configurations and certifications. But it'll be a critical base of the type of information being processed, right, and handled and communicated. So the software is really the entity that's going to need to protect the content, the personal information that's on the device. It's going to be the one communicating with the device. So that's where the software is going to be critical in kind of how it gets connected.
So secure capabilities, secure connections means also cryptography, trust credentials. So which techniques are most relevant today for IoT devices, and how do they apply to real-world use cases like cloud authentication or encrypt communications, just talking about that each device is connected?
Yeah. When it comes to cryptography, the most common ones, we still are using both symmetrical and asymmetrical algorithms. And they both have their use cases where they excel, where they're ideal. Symmetrical algorithms, they're very efficient for being able to process larger amounts of data very quickly, but you have to have some type of a secure mechanism for being able to share those credentials. While the asymmetrical techniques, they have mechanisms for working with, you have public-private key pairs, but these are very processing intensive. So you have to be able to know, when it's appropriate to use the right algorithm at the right time. For the symmetrical encryption, AES is a common algorithm. And for the asymmetrical encryption, there's both RSA and ECC are prevalent mechanisms to use. But in addition, right, a lot of times, especially when we get to things like secured communication, we're able to work with kind of higher level implementations using things like TLS, right, transport layer security. And these are available as middleware libraries and integrated in with some of the communication standards to be able to allow that secure communication. And then all of these being able to leverage either hardware acceleration or advanced security hardware features to be able to really make them efficient and usable on these kind of small microcontroller type devices.
So if I say you quantum computing, what can you think in terms of security? Because the next wave of threats could come from quantum computing. So, and reshaping the encryption standards, probably today's encryption standards. So how is Infineon preparing for the post-quantum era? So what challenges do you foresee for IoT security in the next 3, 4, 5 years?
Yeah, certainly. Because we just talked about some of the security algorithms that are used, right? If we look at that asymmetrical encryption that we talked about, if I put it into one of its highest settings that's typically deployed today, we have the RSA 2048. It's estimated it would take like 100,000 years for a traditional computer to be able to kind of brute force break that level of encryption, which sounds like, hey, great, that's protected forever. But I think estimates right now is if you had a fully functional and optimized quantum computer, like that's now under 2 minutes, right? That's a big difference. 100,000 years down to less than 2 minutes. So it's a little bit scary, but I mean, the sky's not falling just yet, right? Current quantum computers, they're operating at about, maybe we'll say 0.3 to 0.1% of efficiency of where we think someday they'll be. But, there are estimates indicating that, we could see such functionality from quantum computers in like 5 to 10 years. To see them be able to achieve that kind of RSA level encryption cracking. And so now is really the time to start planning, particularly when you think about these, industrial type devices where I could put a product in the field today and it's going to be there for the next 15 years. It is likely going to be there when quantum computing and these risks start to materialize and become real. So Infineon has a variety of PQC-ready hardware. Right? So this is hardware that has been architected with, from a foundation piece, we're looking at making sure it has just sufficient power and memory configuration, that it's got both the hardware and the software that's enabled to provide secure boot and secure in-field updates, whether this is over-the-air updates or over a physical connection. And as well as cryptographic acceleration that is agile enough to be deemed PQC ready, post quantum computing ready. So Infineon is looking at these things. They are putting in the mechanisms, the foundations into the hardware today to be able to ensure that I have a path, right? As we know what kind of the attack vectors and how I need to address the quantum computing effects or attacks, that I'm able to affect those changes in devices, even if they're deployed. And additionally, Infineon's very active, has been actively involved in a lot of the security standards for years, actively contributing to the development of what's referred to as a stateless signature scheme.
Mhm.
So this is a scheme that's currently being standardized by NIST as a SLH-DSA. So Infineon's involved in that. Like I said, sky's not falling just yet, but we do need to think about it today in terms of making sure that I have devices that I've put in the correct mechanisms and hooks to be able to allow a device to be updated in the future to address these issues and these concerns.
Thank you, Clark. Thank you. Very, very, very nice. So I have just a few questions before concluding this very nice embedded edge episode. We have seen different topics in terms of security. I guess covering all topics, just from design implementation. So for many developers, security implementations can be complex. And reference design, any other tools is important. So what projects, what frameworks Infineon is providing to guarantee the best approach for designers to help developers to implement scalable and future-proof IoT security solutions.
Yeah, I think this is now where software and development tools really start to add value. Infineon offers a suite of security-related tools. They're named the Edge Protect Security Suite. And this is a tools package that has several utilities for things like enabling the generation of security keys, right? The public-private key pair allows a developer to define or customize security policies, to be able to generate what's called a certificate signing request file, or it's a CSR. It also includes utilities to help with the deployment of Edge Protect bootloader. Kind of talking through a few more of those. So the certificate signing request file, this is a file that gets generated. It's got all of the details and information about the developer. It is uploaded into an Infineon Edge Protect signing service. So this is a cloud-based service that allows me to upload the certificate, and the certificate is then signed by Infineon, and thereby leveraging the ability to maintain that root of trust we talked about earlier, and transfer the ownership from Infineon to the product developer. So that's the process that's followed to be able to allow a developer to maintain that chain of trust and take ownership of the device. And then I mentioned the Edge Protect bootloader. This is, I'm able to use the Edge Protect bootloader with that signed certificate to ensure that only code that I have signed, only code that I have validated is able to execute on the device, extending that root of trust and chain of trust into the code that's running on the device. And that enables me to have, secure communication and things like that. So, and then in addition to those tools that I'm using, I've got various other foundational elements and various middleware libraries and reference example projects. So inside of our tools, like our Modus Toolbox development ecosystem, I'll have projects that help me to understand and leverage cryptography, TFM, trusted firmware, the device firmware updates and OTA, embed TLS that can do secure communication and other various ways of handling secure communication. So lots of different middleware libraries that I can integrate into my product to be able to help achieve the different security features, different code examples and reference projects that'll really help me kind of understand how they work, to get a kind of a learning exercise of using these different pieces as well. So lots of goodness inside of the various offerings from Infineon there.
Great. Thank you, Clark. So in conclusion, so let's look at the bigger picture. So just practical advice for companies, which are the key takeaways, at least a few, you would like listeners to remember. So when it comes to security, to securing embedded IoT devices.
Yeah, I think the biggest takeaway is probably to understand that, security is a critical part of any modern product. It's not something that you can just kind of ignore anymore. It used to be, say, oh, we'll worry about that later, or it's an afterthought. from the perspective of global regulation, legislation for just the global supply chain aspect, we need to pay attention to those, but as well as the real risk that this can bring to the value of your brand, to the value of your company, right? It's just things you really do need to pay attention to. And, all types of devices are becoming more and more connected. And this is exciting, right? From a customer, right? This is exciting, right? We get to see all kinds of things, all kinds of ways we can use products. But it does bring along challenges. Security of these devices has to be considered. But the level of connectivity actually becomes part of the solution as well, with more and more devices being connected. And the fact that security threats are evolving, it's certainly not possible to prepare for every eventual threat, especially for, these products that can be in the market for 5 to 15 years or even longer. So it's important to consider the ability to have some type of an update mechanism, right? So I can utilize things like OTA, over-the-air updates, device firmware updates mechanisms, to be able to ensure that a product that I'm developing and delivering today has the capability to address tomorrow's security concerns. That's probably the biggest takeaway.
Thank you so much, Clark, for joining us at Embedded Edge. Thank you for your time and stay in touch. Have a good day.
Yep. Thank you.
This episode of Embedded Edge was brought to you by Infineon. Thank you very much, Infineon, for sponsoring us. If you want to learn more about Infineon's solutions we have been talking about today, please check the links on the podcast page at eetimes.com or embedded.com or the Infineon homepage, infineon.com. Thank you.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about embedded systems design. If you are listening to this on the podcast page at eetimes.com or embedded.com, links to articles on topics we have discussed are shown on this page. Embedded Edge is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio, and the producer is James Eade.